ഹായ് സ്റ്റുഡൻസ്, എല്ലാവരും സുഖമായിരിക്കുന്നു എന്ന് വിചാരിക്കുന്നു. ജസ്റ്റ് കീപ് സേഫ് ആൻഡ് സെക്യൂർ. നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പഠിച്ചത് എല്ലാവർക്കും ഓർമ്മ ഉണ്ടാവുമെന്ന് വിശ്വസിക്കുന്നു. നമ്മൾ ഫൈബേഴ്സിനെ കുറിച്ചാണ് പഠിച്ചത്. ഫൈബേഴ്സിൻ്റെ അകത്ത് ഡിഫറെൻറ്റ് ഫൈബേഴ്സിൻ്റെ ഐഡൻറ്റിഫിക്കേഷൻ പഠിച്ചു. ഡിഫറെൻറ്റ് ഫൈബേഴ്സിൻ്റെ ഐഡൻറ്റിഫിക്കേഷനും അത് കഴിഞ്ഞിട്ട് അതിൻ്റെ പ്രോപ്പർട്ടീസും പഠിച്ചു. അതിൻ്റെ അകത്ത് നമ്മൾ പഠിച്ചതെല്ലാം തന്നെ ഫൈബേഴ്സിന്റെ ബേസിക് പ്രോപ്പർട്ടീസ് ആണ്. ഫൈബർ എന്താന്ന് പറഞ്ഞാൽ ബേസിക് വിസിബിൾ യൂണിറ്റ് ആണെന്ന് പറഞ്ഞു. സോ ഇൻ ദ ജേർണി ഓഫ് ഫൈബർ ടു ഫാബ്രിക്, അതായത് നൂലിൽ നിന്ന് ഒരു വസ്ത്രത്തിലേക്കുള്ള ദൂരം. സോ ഫൈബർ ടു ഫാബ്രിക് എന്ന് പറയുന്നതിൻ്റെ ഇടയ്ക്കത്തെ ഇന്റർമീഡിയറ്റ് പ്രോഡക്റ്റ് ആണ് യാൺ. സോ ഇറ്റ്സ് എ ട്രാൻസിഷണൽ ഫോം ബിറ്റ്വീൻ ദ ഫൈബർ ടു ഫാബ്രിക് ആൻഡ് ദീസ് ആർ ദ യാൺ. So from the fiber, yarn is manufactured and yarn is used to construction of fabric. So now we are going to into details about the yarn making and the classification of yarns and the properties of yarns. So just we want to know about the basics of yarn. So this is the portion dealing with the yarn. How can you define yarn? Yarn is defined by the American Society for Testing Materials as a long continuous length of interlocked fibers. Strands of fibers are brought closer to each other by twisting. Twist imparts strength to the fiber strand, which is then termed as a yarn. This yarn is used for the production of textiles, sewing machine, crochet, knitting, weaving, embroidery, etc. For all this, these yarns are made. So yarns are the long continuous structure made from the fibers by interlocking each other. So this is the definition for yarn. This yarn, the classification. The yarns are basically classified into spun or staple yarns and the filament yarns. All of you know what is staple yarns. Staple fibers you know, and you know filament fibers. Staple fibers are the short fibers and the spun or staple yarns are the yarns composed of short fibers or the staple fibers. In the case of man-made fibers, they are the long filament fibers which are cut into short staple fibers and twisted to form the spun or staple fibers in the case of man-made fibers. Then next is the filament fibers. Filament fibers are the long threads extruded from the spinneret for the man-made fibers. They are twisted to form a filamentous long yarns. These are monofilament and multifilament yarns. These most probably all these are manufactured man-made fibers, and as well as natural fibers can also be formed into filament yarns. Monofilament yarn consists of a single strand, but multifilament yarns are made from a multiple filament fibers. So this is the first categorization or the basic classification of yarns, staple yarns and the filament yarns. Next is the tape, network or film yarns. These are produced by splitting or slitting of sheets of materials or polymers which are extruded and solidified. One or more strips are made by lengthwise division of the polymer sheets. Such yarns prove to be cost effective and is extensively used in industrial textiles for packaging. These are the long threads that is cut from a sheet of materials lengthwise, so it can be used as a thread. Most probably it is used in the industry for packaging. You have very familiar with the packaging strands of plastic, etc. These are the tape, network or the film yarns, and the name is come from it is cut from the films or the broad tapes which cut into small threads. Next is the classification of yarns based on the number of yarns. You can we have already studied about the spun yarns and the filament yarns. These are twisted. In the filament yarn, we are classified it into monofilament and the multifilament. So this comes under the multifilament yarns. First is the single yarn, in which single strand is twisted together to form a yarn. In the ply yarn, two or more single yarns are twisted together to form a ply yarn. And the cord yarn is manufactured from the twisting of more than two ply yarns, and each ply yarn consists of single stranded yarns, two or more single stranded yarns. So these are the ply yarns. This is the classification of yarns based on the number of fibers used. Next is the classification of yarns based on visual appearance of the fibers. Which are most commonly used is the filament yarns, smooth filament yarns. These are uniform as they come from the spinneret or from the machine. More luscious than spun yarn depending upon the delusion amount that is. This is about the man-made fibers. These are the smooth film. Most of the yarns used in weaving is smooth filament yarns. Knitting are also used as smooth filament yarns. So these are the commonly used one. Next is the textured yarns. Textured yarns, you can see here all the textured yarns have some variations in it, and these crimps are created artificially, and these types of yarns are known as the textured yarns. Next classification is the simple yarns and the complex yarns. Simple yarns are the names such as high uniform size, regular surface and relatively smooth appearance, and these are the simple yarns. And in the complex yarns, we are seeing in the textured yarn, it is made up of certain striations, knots, loops, etc. to make a fancy yarn or look attractive. These are the complex yarns. This is same as the textured yarns. In the classification, we are already studied the textured yarns. Is the another classification is based on the function, and these are the complex yarns, and these are the simple yarns. Then here ending the classification of yarns. So as conclude, we are classified yarns. Basic classification is spun yarns, filament yarn, taper, network yarns. And the next classification is classification based on the parts, based on the number of yarns used: single yarn, ply yarn and cord yarn. Single yarn is a single filament or staple fiber yarn. Ply yarns are made up of 2 or more than 2 single yarns. Cord yarns made up of 2 or more ply yarns, and each ply yarns consists of 2 or more single yarns. This is the classification. Then the next classification is based on the visual appearance, that is the smooth filament yarns and the textured filament yarns. And on the basis of function, it is classified into simple yarns and the complex yarns. Simple yarns are same as the smooth filament yarns and staple and filament yarns, and it is also same as the single ply and cord yarn. All these comes under simple yarns, and the textured yarns are the complex yarns. Then we studied about the fibers. Now we studied about the classification of yarns. Now we are moving to know about the yarn manufacturing process, or from the fiber how the yarn is manufactured. Before that, just we can go through how the fibers are processed for some of the fibers, from some of the man-made fibers. So this is the cotton plant. You can see this is the cotton farm. This is the cotton pods burst open to collect or the ripened cotton pods. These are also the ripened cotton pods. And this is the farm is ready to harvesting. This is the basic structure of cotton plants. Then this is the harvesting process. This is the man-made manual harvesting process. They plug the cotton pods. Burst, opened, ripened cotton pods are collected by them, and these are sent to the machinery in the field itself. And this is cleaned. The lint is removed. The seeds are removed, and the cotton fibers is taken, cleaned, removed the dirt and dust particles. Lint and seeds are removed, and the cotton fibers are collected. This is the process of ginning. And the ginning, in this process, the seeds, the lint and the impurities are removed, and this is the ginning process. This is to do different types of ginning process. The first ginning process, the man is beating with a wooden stick and beats and the impurities, seeds and the lint will settle down, and the fiber is taken from the heap. This is one portion, one type of ginning process. And this is the next ginning process. The fibers, the cotton is pulled in the machine and it is rotated, where the seeds and lints are deposited down portion, and the fiber is extracted. This is the manual ginning process. And then these ginned cotton fibers are then compressed into bales weighing approximately 500 pounds. These are tightly bonded and these are formed into a bale. This bale is sent to the yarn manufacturing mill or spinning mill. This is a mechanical harvesting process in which the machine harvests the cotton, it processes it and make into a bale. This is the bale by the machine, and from the fern portion it is harvesting the cotton plants. The cotton plants are harvested, the cotton balls are beaten, the lint and seeds and other impurities are removed and made into a bale. This is a mechanical process completely driven by the machine. And here the complete process, the harvesting, ginning and baling is a continuous process, and these bales are sent to the spinning mill. This is the wool processing, and here we get the fibers of the cotton. Then we are moving to the wool processing. In the wool processing, the animal is slaughtered or sheared. Here I am showing the shearing process. The cotton, the wool is sheared from the sheep. Then they are graded from. As we already studied, there are different grades and different types of wools. So it is graded based on the quality, the length, etc. Then they are sorted. The sorting from different parts of the fibers from different parts of the sheep have different qualities. So they are sorted based on the color, based on the quality, length, etc. They are sorted. Then they are cleaned. That is a scoring process. In the soap water, it is thoroughly cleaned to remove the dirt and dust particle, as it is the hair of the sheep or the like animals. It may contain dirt and dust particles. So in the cleaning and scoring process, it is completely thoroughly washed in the soap solution and cleaned and washed. And after washing, these are dried in a drying machine. This is the drying process. This is dried in a machine and then baled. As in the cotton, it is baled by the baling process. This is a manual baling process. The same process is carried out in the machine also. And this is the steps in the wool processing from the farm to the spinning mill. And it is the manufacturing of fiber of wool fiber. Then so we are now know how the fibers are extracted from the cotton pods and also from the sheep. Then next is and both these are sent to the bale opening section, in where the bales are cut open. Then they are blowed to remove any additional dust or dirt particles or segmented particles are there. They are removed in the blow room processing. Here all the entangled process fibers are detangled and made into fluffy stuff. So this is the process. Here the bale is open. Then in the bale room, it is fluffed open, almost equivalent to the ginning process, but it is carried out by the machine. For any type of impurities are there, they are all removed by the blow operation. In the next section, all these fibers are passed through a carding machine. This is a card, and you can see there are sheets are formed, and the sheets from the fibers. Sheets are formed. These sheets are rolled into a bale. This is the carding process. In the carding process, all the fibers are entangled and pressed between two rollers. This is the two rollers by which they are pressed. In between these rollers, they are pressed to form the sheet. These sheets are rolled in the bale to form a roll. This roll is then passed to the combing process. Here, this is the comb. These are the combs. This is situated here. Then these cards are passed through the combing machine and forms the small fibers like this. These fibers, this is the fibers formed by the combing process. These are the fibers formed by the combing process. These fibers are twisted, just pull out, stretch to make a small fibers, and these are rolled into a bale. And these bales are sent to the spinning mill. This is a slivering process, and the resulting portion is known as the slivers. These are the slivers formed by the slivering process. Then these slivers are reeled and sent to the spinning mill. You can see the slivers here. These are the slivers. This one is the unbleached cotton slivers, and this is the bleached cotton fibers. So it is too white. These are too white because this is the bleached cotton fibers. This is a silk production or the sericulture. Here we can see the healthiest moths or larvae are collected, and these are the eggs. These eggs are healthy eggs are collected, and they feed on the mulberry leaves, and then they become a larva. These larvae are after 20 to 35 days they form the cocoon. These cocoons are after maturing for 35 days. Before the butterflies are coming out, they are taken, and the moths are killed by dipping in a hot water, and then these cocoons are dried. These cocoons are dried and undrilled to form the fibers. Silk fibers are formed. This process is or this branch of science is known as the sericulture. This is the real pictures. These are the silkworm. These are the Bobix mori silkworm. These are feed on the mulberry leaves. After occurring a growth of 25 to 30 days, they are transferred to the reel. This is the reel. They are transferred to the reel. In the reel, they start to form the cocoon. After 30 days, they can completely cocoons are formed and they become mature. These are the ahimsa silk known as from which the butterflies are come out as a live organism, and the remaining cocoon is collected. And naturally, this is known as ahimsa silk because we are not destroying any pupa or any moth inside the cocoon. But in this case, we are destroying we are boiling the cocoons, and we are destroying the larva or the butterfly inside the cocoon itself. Then these cocoon from both 1 and 2, the cocoons are collected and the fibers are unrilled. You can see the fibers here. These fibers are undrilled. Then they are formed to a continuous fiber in this machine. So in both these three cases, in the case of cotton, wool and silk, the long threads or slivers are formed. This is another method. It's a degumming process. This is a special process of silk threads. As such, we can see here these have gums in them. This is known as the raw silk. They are not thoroughly washed. Second is it is just dipped and washed in hot water only. That is, they have some portions of gums there. These are the better method. They are washed with soap water and completely the gum portion is completely removed. Silk threads are here. Then this is degummed by citric acid, but citric acid will adversely affect the structure of the silk fiber. This process is the boiling of not boiling. It is the washing of cocoons in soap water to remove the gums, and this is known as the degumming process. Then weighing of silk. While degumming, it loses the resin content and it reduces the strength of the silk fiber. To get the strength and the weight of the silk fibers are weighed. weighing process is it is applied with the silicate solution or metallic solutions to form a layer of metal ions around the silk thread, and so this is known as the weighing process. It is treated with the proper silicate solutions. It will give weight to the silk fiber, and the weight reduction due to the loss of resin will be made to normal. This is the two types of silks, as you already said it, mulberry silk and the merino silk slivers. This is processed from this machine. From this machine, the decommed silk slivers are formed. By now we have the slivers of cotton, wool and the silk. Both these slivers are available with us, or the sliver manufacturing we already studied. From these slivers, yarns are manufactured. Then the yarn production process. Yarn is produced by drawing out and twisting a group of threads under pressure, or the slivers. This is the group of threads are known as the slivers. And until the sliver processing, it is not in a textbook, but for general information I have added that to this, because there's no about the processing. On the basic of processing, it is not a detail, it is in a capsule form, just the basics of the fiber to sliver formation. In the bare minimum knowledge you want to, I think it is beneficial for you to know the yarn. Okay, then from these slivers yarns are produced. This is a yarn producing machine. These are the slivers, you can see it clearly here. These are the sliver bins from which slivers are taken and the fibers are formed. Then spinning process. The process of making yarns from the textile fiber is called spinning process. Spinning is the twisting together of drawn out strands of fibers to form a yarn. Oh, this is the spinning process, and this is the spinning mill. And from the yarns, from the fibers, the yarn is produced, and it is produced by slightly pulling out under pressure and giving a twist to form a small continuous thread. That is the spinning process. Then first one is the spun yarn production. Spun yarn is produced by three techniques: conventional or mechanical spinning, non-conventional spinning, and from manufactured filament fibers or the man-made fibers. First, conventional or mechanical spinning process. In the mechanical or conventional spinning process, there are the ring spinning process. In the ring spinning process, we have seen the slivers. Slivers are twisted under pressure and slightly pulled out to form a thin strand. These are wounded on a spool. These are the spools. These are the spools in which these are the slivers. These slivers are pulled out to form pulled out and twisted to form the threads. These are the threads. These threads are wound on a spindle, and this is a continuous process. This is continuously come to this. So this is a continuous process. So this is known as the ring spinning process. Next is the non-conventional spinning. This is a new spinning technology to increase the productivity, improve or at least retain yarn quality and ensure increased efficiency in subsequent processing. Fabrics made from yarns made out of a non-conventional spinning system are different in their properties and other functional aspects. The main non-conventional spinning systems are fasciated yarn spinning, rotor spinning and friction spinning. This is the first one is a conventional spinning process in which yarns are formed from the slivers directly pulling out, twisting and wounding on a spool. But in a non-conventional spinning method, there is no drawing out or twisting. The other methods are used to join the fibers together. First is the fasciated yarn spinning, rotor spinning process, or the open end spinning process. Here the sliver is fed in the rotary beater. the fibers in the ducts and get deposited on the sides of the disc or the rotor. Turning the rotor, there are two types of rotors. This is the rotor spinning process. By the movement of rotors, this is the rotor, opposite spinning of the rotor, a fiber is formed. This is the feed plate, this is the sliver, this is the two rotors. These are the two rotors. By passing through this, the spinning is formed and there are fibers are formed. These are the two rotors. Between this, the sliver is passed and the fiber is formed. After the fiber is formed, these fibers are wounded on a spindle separately. So this is the rotor spinning, or it is known as the open end spinning process, because the twisting out and spinning is a yarn formation is a single process, from where the slivers are pulled out, twisted to form a yarn. These yarns are wounded on a spindle by a separate portion. So this is the two portions. So it is known as a open end spinning process. The drawing out and twisting is one operation, and the yarns are formed. These yarns are wounded in a spindle in a second machine or in a second process. So this is known as the open end spinning or the rotor spinning process. Then the friction spinning process. This is also one type of open end spinning. In the rotor spinning, you can see it is the air current turns the rotor and forms the convolutions, or the twist is formed. It is a constant stream of fibers are allowed to flow through the rotating yarn ends, and a brush-like machine is used to twist the fiber to form a continuous thread. But in the friction spinning process, it is carried out by the friction between two rollers. You can see it. This is the friction spinning, basic functioning of the friction spinning. Here the two rollers are there. From the friction between these two rollers, the twisting is formed. നിങ്ങൾക്ക് എല്ലാവർക്കും അറിയാം തിരി കിടക്കണം, നമ്മുടെ രണ്ട് കൈകൾ ഓപ്പോസിറ്റ് ഡയറക്ഷനിൽ മൂവ് ചെയ്യുന്നു. അതുപോലെ ഇതിൻ്റെ അകത്ത് രണ്ട് റോളേഴ്സ് ഓപ്പോസിറ്റ് ഡയറക്ഷനിൽ മൂവ് ചെയ്യുന്നത് മൂലം ഉണ്ടാകുന്ന സ്ലൈവർ ഫെഡ് ചെയ്യുന്നു. അതിൻ്റെ അകത്ത് രണ്ട് റോളേഴ്സ് 1 ഉം 2 രണ്ട് റോളേഴ്സ് ഓപ്പോസിറ്റ് ഡയറക്ഷനിൽ സ്പിൻ ചെയ്യുന്നത് മൂലം ഉണ്ടാകുന്നതാണ് ഫ്രിക്ഷൻ സ്പിന്നിങ് പ്രോസസ് എന്ന് പറയുന്നത്. ഇൻ ഫ്രിക്ഷൻ സ്പിന്നിങ് യൂസസ് ടു ഫ്രിക്ഷൻ സർഫസ് ടു റോൾ അപ്പ് ഫൈബേഴ്സ് ഇൻ ടു yarns. The fibers flow freely to two rotating friction drums. Here is the two rotating friction drums. Then the surface at the nip of the two drums move in opposite direction to twist the fibers collected on the nip. Then integrated composite spinning method. This is also referred to as trifler spinning. In this method, the resin is fed into the system in the pellet. Resin is a binding substance. It is deposited in the machine in the pellet form. It is melted to form the spinning solution to serve as the bonding agent. Then the filament fibers is passed through and coated with the polymeric resin. The fibers, the slivers are passed through it is slightly pulled out to form a thin fiber, and this fiber is passed through this resin solution, polymer resin solution. By passing through the polymer resin solution, a thin coat of polymer resin is formed on the outer surface of the fiber, by which these fibers are combined together to form a single thread. This is the integrated composite spinning process. Then a predetermined variety and length of staple fibers is superimposed upon the bonded by compression to the polymer cotton continuous filament fiber. Then this is covered with a staple fiber to form the particular structure. You can see it here. Here it is passed through the polymer then form the fiber or yarn. This is passed through a staple fibers. So these staple fibers, these are the staple fibers. These are the staple fibers adhere to the cotton. This is the cotton resin. This is the fiber. This group of fibers are coated with the resin, and before it is dried up, staple fibers are compressed on them to form the integrated composite yarn. We can once more go through the written part. This is the resin is fed into the system in pellet form and melted. Then the filament fibers is passed through and coated with the polymeric resin. Then a predetermined variety and length of staple fibers is superimposed upon and bonded by compression to the polymer to form a continuous filament core. Give a twist at high speed, cooled and wound on spools. This is also done in a continuous sequence of operation in one machine at rates of up to 2500 feet per minute. So this is the integrated composite spinning process. Then fasciated yarns. You know what is fasciation. Kettuga. That is fasciated. So fasciated yarns are the consisting of a core of parallel fibers held together by wrapper fibers. You can see here, these are held together by a wrapper fibers. So this is the fasciated yarns. This yarn is essentially that of comparatively straight central core and of fibers held together by taut surface fibers wound onto the central core helically. The straight fibers termed as core fibers, while the taut or helical fibers are called as wrapper fibers. You can see the diagonal fibers are the helical fibers and the straight fibers are the core fibers. This is the fasciated fibers. Yarns. Then the self-twisted yarns. This is the pair of roving is passed through two rollers which are oscillating as well as rotating in opposite directions. Each imparts a twist and converts the fiber into a yarn. After leaving the rollers, the two yarns are held together. So you can see here from the slivers, it is passed through oppositely rotating two sets of rollers. These are the two sets of rotating rollers on the opposite direction, self-rotating and moving into the opposite directions. By this, yarns are self-twist yarns are formed and wounded into the spool. This is a self-twist yarns. Then next is the man-made fibers. These are the filamentous yarns. And man-made yarn production is the chemical spinning process. So for man-made fibers, previous from the fiber to yarn, there is no processing. It is directly we are forming a solution, and this solution is passed through the spinneret. This is the spinneret, passed through the spinneret to form a long continuous thread. This is known as a chemical spinning. So because chemical solutions are passed through the spinneret, so it is known as the chemical spinning process. Man-made fibers are produced by converting the fiber-forming substance to a viscous fluid that is extruded through the holes of a spinneret and then solidified by coagulation or evaporation or cooling. So this is the chemical spinning process. The process of chemical spinning is classified into pre-spinning process, actual spinning and the post-spinning process. In the pre-spinning process, the spinning solution is formed or spinning solution is manufactured. In the spinning solution itself, the delustrants are added, bleaches are added, optical brightening agents are added, and dye pigments are added. This is the pre-spinning operation. This is the formation of the spinning solution. In the actual spinning process, the solution is passed through the spinneret. In the actual spinning, it is classified into merge spinning, dry spinning, wet spinning, emulsion spinning, and the gel spinning process. In the merge spinning process, the polymer is heated and melted to form the liquid spinning solution. In the pre-spinning, there is a solution is formed. The solution is formed by the melting process. the chemical substance are melted to form the polymer solution, and this melted solution is passed through the spinneret. In the dry spinning process, here a volatile solvent like acetone. നിങ്ങളുടെ നെയിൽ പോളിഷ് കളയുന്ന സാധനമില്ല, നെയിൽ പോളിഷ് റിമൂവർ എന്ന് പറഞ്ഞാൽ ഇവാപ്പറേറ്റ് ചെയ്യുന്നു. സോ ദാറ്റ് ഇസ് എ വോളറ്റൈൽ സബ്സ്റ്റൻസ്. അത് ഇവാപ്പറേറ്റ് ചെയ്തു പോകും. സോ the chemical substance or the raw material is dissolved in a volatile substance. Acetone പോലെയുള്ള volatile substance dissolve ചെയ്യുന്നു. So when it is open to the atmosphere, what will happen? The acetone will evaporate and the solidified substance, the raw material is formed into a yarn. The same principle is applied in the dry spinning process. In the dry spinning process, the chemical substance is dissolved in a volatile substance. This solution is passed through the spinneret, and while passing and extruded through the air chamber. In the air chamber, the acetone or the volatile substance evaporates, depositing the actual raw material in the form of a fiber. That is a dry spinning method. In the melt spinning, polyester and nylon is manufactured by the melt spinning process. Cellulose acetate is formed by the dry spinning process. Next is the wet spinning process. It is the oldest and the most complex process and the expensive method of man-made yarn manufacturing. In this, a non-volatile solvent is used to convert the raw material into a solution, and this is passed through a bath solution where it solidifies. So it is the wet spinning method because it is passing through a acid bath. Is a liquid solution, and directly this solution in the spinneret passes through the bath or a liquid substance, maybe acid or any substance that solidifies the yarns. So it is passing through a liquid substance, so it is known as the wet spinning process. It is as such, as previously we said, it is formed into a solution, then it is dissolved in a chemical bath, and it is dissolved to form a solution. This solution is passed through a acid or basic bath based on the chemical substance extruded, and in contact with the solution, the solution from the spinneret solidifies and forms into a yarn. So it is known as the wet spinning process. Next is the emulsion spinning process. In the emulsion spinning process, the polymer is made into an emulsion. The solution using in the spinneret is in the form of an emulsion, and this emulsion is passed through the spinneret to form the thread. Next is the gel spinning process. The polymer is mixed with the solvent to form a gel, and this is passed through the spinneret to form the man-made fiber. So these are the different process by which man-made fibers are formed. Then next is the post-spinning process. After the formation of fiber from the spinneret and solidification of the fiber, these are drawn out, washed thoroughly to remove the chemical substance present in them, then spin for the finishing, heat set and wounded into the spool and sent to the weaving mill. Then yarn from manufactured filaments. The introduction of man-made fibers has boosted the development and processing technologies, which are partially or totally innovative as compared with the world of natural fibers. Some processes were adopted to change the fiber typology. All these fibers are of same typology. To change their typology, certain additional processing are given to the man-made fibers. These are the top-to-top conversion process. It is the direct transformation of a cable of continuous filaments into a sliver of discontinuous fibers or staple fibers, because long fibers are formed by the chemical spinning process. These long fibers are cut into staple fibers or small fibers to form a staple fibers. This is known as the toe-to-top conversion process, or it is a process of converting filaments fibers to a staple fiber. First toe-to-top conversion is carried out by the breaking technology. It consists of drawing the filament yarn gradually in a controlled way until the breaking point of the fiber is reached. It is stretched to that point that it breaks, and it stretched up to the breaking point to form a staple fiber. So this is the toe-to-top stretch breaking technology. So the toe-to-top conversion. Toe means staple fibers. Toe means filament fibers. Top means staple fibers. It is the filament fibers to the staple fiber conversion. So it is converted if it is by the stretch breaking. By giving a pressure, a stretch is given and the filament fibers is broken at the weakest point. This is known as the toe-to-top stretch breaking technology. Next is the toe-to-top cutting technology. This is the cutting technology. The name itself clears that it is cut into small fibers. The toe or the filament fibers cut of same length to form the staple fibers. This is the toe-to-top cutting technology. So this is the one conversion of the filament fibers to the staple fibers. Next is this is a stretch break converter. This is the machine used to stretch breaking. It can be so clear. That is stretch breaking on. This is a fiber cutting converter. Just for the general information. Then next is the direct toe to yarns or the direct spinning method. In this, the extruded toe is fed to a special draw frame. The drafting roller stretch it to the required thinness to break it into shorter length. This is directly carried out from the spinning machine. We are saying the spinners and the chemical spinning process. It is directly from the solution. A yarn is formed. This yarn is directly drawn into a frame and they are drafted to staple fibers. This is a schematic of the direct spinning process. Here directly it is processed from this spinneret. It is directly to cut into a toe or the yarns is directly formed. The thinners to break it into shorter length. Then the thinners are braid it into shorter length. This is the direct toe to yarns process. Then this is the direct spinning machine. Then properties of yarn. I think you get the detail about the yarn manufacturing process. Can we repeat these things? There are two types of process: chemical spinning and the mechanical spinning. Mechanical spinning, there are conventional and non-conventional methods. Then the chemical spinning process. In the chemical spinning process, there are wet method, dry method, immersion method and gel melt, dry, wet, immersion and gel methods. These are the different methods of spinning process: melting process, dry, wet, immersion and gel process. Then these filaments yarns are converted to staple yarns by toe to top conversion. Then direct toe to yarn conversion. These two methods are used to convert the fibers to man-made filamentous fibers to yarns. Then we are moving to the properties of yarns. Their different properties are grouped into two: yarn twist, yarn count or number. In yarn twist, there are two characteristics: the amount of twist and the direction of twist. Yarn twist, the amount of twist and the direction of twist. Then the twist in the yarns may be put either to the right, the S, and to the left, the Z. This is the twist. If it is to the right side, it is S, and if it is to the left side, it is Z twist. This is the Z. We can make it Z. If it is to this direction, we can make a S. So this is the direction of twist. The right is the S twist and the left is the Z twist. Then the amount of twist or the twist per inch. The twist that can see in a unit length of the yarn. This is important, the unit length of the yarn. So it is the twist per unit length of the yarn, unit length of the yarn. That is TPI, or twist turns per inch. This is TPI. This determines the length and the fineness of the yarns. Generally, filaments need a twist of 3 to 6 TPI. It is the lowest twist turns are soft, fluffy, warmer, but 10 to 20 is the highest. This is a good quality yarns, and as the twist increases, it becomes coarser. As the twist decreases, it becomes fluffy, soft. Then the yarn number. In textiles, yarn count is the number that represents the diameter or the fineness of a yarn, either in terms of weight by length or length by weight. The direct system measures the weight of a consistent length of yarn. A yarn with higher yarn count indicating a heavier and coarser. As the number of yarns used increases, the coarseness of the yarn also increases, as well as its weight also increases. So that is the yarn number. As the number increases, its strength also increases, as well as the weight increases, as well as the coarseness of the yarn also increases. Thank you. Hereby we are stopping the portion here, and by this we completed chapter 7. Thank you.